I'm Anil Kumar. Welcome to my series on relative velocity. The question here is, a boat is capable of 20 kilometers per hour in still water. You wish to cross the river downstream so that the angle the boat's push makes with the bank is 50 degrees. At what angle to the bank should the boat steer if the current is 8 kilometers per hour? How long will it take you to cross if the river is 1.7 kilometers wide? You can always pause the video, answer the question, and then look into my suggestions. Now, let's make a small sketch here to understand the situation. So we'll consider two banks of the river which are parallel and straight. Right? That is the first assumption. So what we have here is that we need to make an angle of 50 degrees with the bank, right? So let's say this is the direction in which the boat moves, and the angle which it makes with the bank here is 50 degrees. We are also given here that the width of the river is 1.7. So let me just sketch here a dotted line saying that this width is 1.7 kilometers. Now to reach at this place, the boat has to steer somewhere in this direction, and then water is going to push it down, right? The speed of the boat is 20 kilometers per hour, and that of the river is 8 kilometers per hour, right? So that is the speed. So let's just say that you actually head in this particular direction with the velocity of 20 kilometers per hour. So that is kilometers per hour, but the river pushes you with 8 kilometers per hour downstream so that you reach the point. So that is the kind of velocity diagram which you can have. We have actually also introduced the position here, since we need to find how long will it take to cross the river. So we added this at the end. Okay, now let's start working on the angles which we know. We know that these two sides of the river are parallel. That being the transverse, we know this angle is here 50 degrees, right? Now if you know a combination of an angle and the opposite side, you can use sine law to solve the particular triangle, correct? So let's solve this particular triangle. Let's label this. Let's say this is a position A, you are heading towards B, and you land at C, right? So from here we can find what is the other angle, right? So the angle at which you need to go. So this angle, which is angle, we'll call this angle alpha. So let's say this angle is alpha. So in that case, sine alpha over the side opposite to it is 80 kilometers per hour, right? 8 kilometers per hour, we'll write 8, and sine of 50 degrees over the velocity of boat, which is 20. So from sine law, we get this equation. And from here, we can find what alpha is. So we know that sine alpha is equals to 8 over 20 times sine of 50, right? So let's calculate this value. So 8 divided by 20 times sine of 50 is equal to 0. So we can say alpha is sine inverse of this particular thing, which is 0.3064, right? So we got this as 0.3064, right? So we'll do now sine inverse to find the angle alpha. Shift sine inverse our answer, and that gives you 17.84. So we get alpha equals to 17.84 degrees. So we know now the angle alpha for us. So first thing is, at what angle to the bank should the boat steer if the current is 8 kilometers per hour? So with the bank, it becomes 50 plus whatever you get. So the angle which you have to write here is basically sum of these two. So with the bank, it is this angle which you have to report. So the angle with the bank will be let's call this as beta. So that should be equal to 50 plus 17.84. Correct? So let's add them up. So when you add 50 to this, so it becomes, we can round this to 0.8, right? So 67.8. So that's the angle with the bank. Correct? Now the second part to this is, how long will it take you to cross? Now we need to find the resultant velocity and also the distance. So these two things we have to find to figure out how much time will it take. So to find the resultant velocity, we'll again use the sine law. Now we should know what this angle is, correct? So that angle we need to figure out, and then we can again use sine law. So let's find the angle at B first. So which should be 180, take away 50, right? Take away 17.84, and that gives you 112. So this angle here is 112.16, right? So that is the angle which we get on the other side. Okay, so we find that the angle at B is equal to 180 degrees minus this 50 degrees minus what we found as alpha, which is 17.8, and we get that as 112 point, we'll write 16, right? So we'll use 4. It's a good idea to use two decimal places for calculations, since there could be huge errors, right? Okay. Now, knowing this angle, we can find the resultant velocity. Let's call this as VR. So the resultant velocity VR over sine of the angle, which is, so we are again applying the sine law, right? So again sine law. So sine of angle 112.16 should be equal to what is known to us, which is 20 over sine of 50. So the resultant velocity is 20 times sine of 112.16 divided by sine of 50 degrees, correct? Okay, so that gives you 20 times sine of 112.16 divided by sine of 50, and that is equal to 24 point, let's say 18, right? So kilometers per hour. Now we also need to find distance A to C, right? So what is distance A to C? The distance A to C through which the boat actually travels can be found from the triangle. Let's call this point as a point P. So in this triangle, you see P is at right angles, and therefore we could say that AC, well, we can write in this particular triangle, if you look from the 50 angle, then 1.7 becomes the opposite side. So we can say sine of 50 is 1.7 over V of R, right? So V of R, which is AC, is equal to 1.7 times sine of divided by sine of 50 degrees. Correct? So how did I get that? Let me, actually I jumped into this anyway. What I did was, actually I wrote 7 sine of 50 degrees is equal to opposite side of 1.7 over VR, correct? And then we cross multiply it. So we get 1.7 divided by sine 50. So 1.7 divided by sine of 50 gives us the distance, which is equal to 2.219 kilometers. So now we know the distance. Once you know distance and the speed, right, so the velocity is 21.18 and the distance is this. So the time taken, let's say time t, is equals to velocity r over, distance AC over the velocity, which is VR. We can now find AC is 2.219 divided by 24.18. 2.219 divided by 24.18. That is equal to, in decimals, 0.091. Now, this is in hours, right? So we'll multiply this by 60 to get in minutes, which is 5.5 minutes. Correct? So we multiplied this by hours, so 1 hour equals to 60 minutes. So we multiply to get our answer in minutes. So the boat will take 5.5 minutes to cross the river, right? So that is how you're going to solve this particular question. I hope it is straightforward and simple. Here is another practice question for you. So follow the same lines and then try to solve the second question, which is very similar, right? So here is your second question to answer. I hope you find it not difficult. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. Here is, a boat is capable of 20 kilometers per hour in still water. You wish to cross the river to a point 0.6 kilometers upstream from your present position. If the current is 8 kilometers per hour and the river is 1.5 kilometer wide, at what angle to the bank you steer the boat? How long will it take you to cross? You can always pause the video, answer, and then look into my suggestions. So let's first make this sketch. Let's say this is the river. The two banks are always assumed to be parallel in such situations. And what is given to us is that the boat in still water is 20 kilometers per hour and you wish to cross the river to a point which is 0.6 kilometers upstream. So you want to go from here somewhere like this, right? So if I choose this to be my opposite side, then this distance is 0.6 kilometers, right? So that is what is given to us. Let's say this point is A and you want to reach at B. If the current is 8 kilometers per hour and the river is 1.5 kilometer wide, at what angle to the bank you steer? So now the current is 8 kilometers per hour. So we'll assume the current to be in this direction because we are going upstream. Now that current is going to push the boat downwards. So that means we should be heading much steeper, right? So we should be heading in this direction so that the current will push it down, right? So to wherever we want to go, right? So that is what is the situation, right? Now this velocity is 20 kilometers per hour. And this for the water is given to us as 8 kilometers per hour. Does it make sense? Correct? So that is what it is. And whenever we say at what angle to the bank you steer, now in this particular case, we are interested in finding this particular angle, correct? That is the angle we need to answer. We'll call this angle as theta. This is what we need to find out. So if you look into this diagram, then this becomes that angle theta, right? So we'll try to find what this angle theta is. Okay, so that's the question. We are also given that the river is 1.5 kilometer wide. So we'll just write 1.5 kilometers here as the width of this river. Now, we know that the width is 1.5 and this is 0.6, so we can find that angle. That is good. Let's label it AB. Let's call this point as C and let's call this point as O. So in that case, the angle, this particular angle, let's call this angle as let's say alpha. So in that case, we know these two sides, so we know tan of alpha is equal to 0.6 over 1.5. So alpha is equals to tan inverse of 0.6 over 1.5. So let's find this angle first. So we have shift tan inverse of 0.6 divided by 1.5, that is 21.8 degrees. So we get this angle as 21.8 degrees. Now if you look into this side, these two are parallel. So this angle of 21.8 will be, let's actually kind of draw like this, a line parallel to this, right? So this angle will be alpha, right? Plus 90 degrees. Do you see that part? Correct? So if you see it, so the angle at B will be what? So now from here we get angle ABC, AB and C is basically equal to 90 degrees plus 21.8 degrees. Correct? So we'll add 90 degrees to this and find our angle, which is 111.8 degrees. So the angle ABC is equal to 111.8 degrees. So we get this big angle, right? Now we know the combination of angle and the side opposite. So we can use sine law. Perfect. So now we can use sine law to solve our triangle. Perfect. So that is what we are going to do now. So we know this combination. We can find the angle theta, but before that we'll have to find this angle. Let's call this angle beta. Okay, so too many alpha betas. Okay, that's fine. So we know sine of beta over the side opposite is 8 should be equal to sine of the angle 111.8 degrees over 20 kilometers. Is that clear? So sine of beta will be equals to 8 over 20 times sine of 111.8 degrees. So the angle beta will be equals to sine inverse of 8 over 20 times sine of 111.8 degrees. Perfect. So let's figure this out. So we have 8 divided by 20 times sine of 111.8, right? And we'll find sine inverse of this number. Shift sine inverse of our answer is equal to, and we get here angle beta equals to 21.8. So that is also 21.8. Okay. Now, since we know these two are 21.8, we can find what theta is, right? So this is also 21.8. So now we know that theta should be equal to, now since this is 90 degrees minus 21.8 degrees, which is alpha, minus 21.8 degrees, which is beta, right? So that gives you the angle theta as equal to 90 minus 21.8 minus 21.8. So that gives you 46.4 degrees. So we have found the angle, which is this angle. We also find all other angles in this particular diagram. Now this angle 46.4 is also the angle here, right? So we know our triangle and its angles. Now let us, so we have one of the answers, which is that the theta angle is 46.4. So this is 46.4 degrees with the bank. How long will it take to cross? So basically now we need to find the resultant velocity and this distance also. So let's find that out. Okay, so let's find resultant velocity first, which is, again, we have to apply the sine law to find this particular resultant velocity, right? So what we get here is, let's write down. So VR, the resultant velocity over the angle opposite, which is sine of 46.4 degrees, should be equal to 20 over sine of 111.8. You can actually find this as a ratio. It is simpler to work with ratios, right? So from here, we know VR will be equal to product of 20 times sine of 46.4 divided by sine of 111.8. 20 times sine of 46.4 divided by sine of 111.8, right? So it is equal to, okay, so this is equal to 15.598, let's say 6. Okay, let's call it 60. So that is the resultant velocity, 15.60. Now, let's find the distance A to B. So I'll find the distance A to B here using Pythagorean theorem, right? So AB will be equal to square root of 1.5 square plus 0.6 square, right? So let's find the distance A to B. So it is square root of 1.5 square plus 0.6 square. That is equal to, in decimals, 1.615. Okay, so that is the distance. So what is the time? So we know time t will be equal to 1.615 divided by 15.60. Since time is equals to distance over velocity, right? So we are writing this. Okay, let me push the page a bit. So that is the distance with us. We'll divide this by 15.6. We get this time in hours and we'll multiply this by 60 to get it in minutes. And in minutes, it is 6.2 minutes. So we'll multiply all this by 60 to get time as 6.2 minutes. Is it clear to you, right? So this time will be in hours, and what we did was that since we know there are 60 minutes in an hour, right? 60 minutes in an hour, we multiplied by 60 to get our answer. So our answer is 6.2 minutes, right? So we get our answer that will take 6.2 minutes. Now you could also write this as in minutes and seconds if you wish to, right? So we get 6.2 minutes to cross. Okay, so this is kind of approximate because we did some approximation, but I hope you understand all the steps involved. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.